Say a kid has to, not exactly color, but has to paste on the structure a red, if not blue triangle, and in place of rectangle, we have three options. How all this kid can do? How many different ways of doing it? So we're looking at that. So this entire chapter has to do with counting, right? So how many different ways can a kid do this? So that is your first way. Count 1, count 2, count 3. So basically we saw that there are 6 different ways, right? 6 ways of doing whatever we just saw. Now, what if we had, in place of 3, we had 4? Okay. How many different things or combination can a kid have? Let's have a look at that. There are 8 ways, right? So what is that? What is the idea behind it? Are you able to derive something? See, listing them is never a good idea. That's what the whole funda of the chapter is. It's not an effective way of looking at things. But if you want to understand how can we get, right, all the possibilities, think of all the possibilities, or at least understand how many possibilities are there. So what can we do? We can make use of fundamental principle of counting. Okay. So basically, to answer this, we'll be using fundamental principle of counting. So what does it talk about? How does it help? If an event can occur in m different ways, following with another event occurring in n different ways, then the total number of occurrence of an event in the given order is m cross n, or m into n actually, not cross, m into n. For example, we had 2 triangles, not 3. We had 2 triangles and we had 3 rectangles to begin with. So basically there are m different ways of selecting a triangle, and there are 3 different ways of, or n different ways of selecting a rectangle. So what is the final way? How many possibilities are there? There were 2 into 3, that is 6, right? Similar stuff, we have 2 triangles and 3 rectangles, right? The total possible ways were 2 into, not 3, sorry, 4. So we saw that we had 8 different ways, right? So I think I have, few more things to add to this particular discussion. Here the sample space is all the possible combination of triangle and, okay, not square, rectangle. So these are independent. What are independent? The selection of a triangle and a square is independent of each other. What triangle we choose, what square we choose, say a kid will not mind, right? He or she loves or he loves all the color combination and everything. So they are independent of each other. The selection of one will not affect the selection of other. Mutually exclusive. If we have to choose one square, in this case rectangle, then the event of choosing a square 1 is mutually exclusive of choosing square 2 and 3. What I mean is, if I happen to pick white, obviously I can never pick an yellow or a green or a purple rectangle. Okay guys. So again, we'll try to reintroduce the idea as and when we can. So here the basic thing is you need to write the heading. Okay, and then the statement. That's it. That's enough.